We'll go fairly quickly on this. And the first speaker is going to be Anjul Bhambhri. Anjul is the VP of Big Data at IBM, and I have had the privilege of going to a couple of her classes already, so may I say she's been a teacher of mine, and I'm looking forward to hearing what she does on introducing us to the big data concepts. Thank you.
Thanks. Hi, I'm Anjul Bhambhri. I'm the VP of Big Data Products at IBM, and it's a great pleasure to be here and to be on a panel talking about big data, hearing all of your thoughts. But before we do that, I'll just spend a few minutes sharing what we have learned and what we've done in the big data space, and how we are seeing different verticals leverage this data and what kind of outcomes have they seen. So I'll take a few minutes and do that, and then hopefully have a good discussion today. So I think you would have seen lots of numbers that get floated around, that 2.5 quintillion bytes of data getting generated every day. So in terms of, if you look at various like analyst reports and stuff, that 90% of this data in the world is supposedly being created in the last 2 years. So in terms of sheer volume of data that we are seeing, we've not seen this kind of data before. And a lot of this data is coming from, that is, all of us are generating this data. So it's human data in terms of like social media, what people are doing on Facebook, on Twitter, and blogging. A lot of it captures, the human behavior. But it's not just human data. There is data that is getting generated by sensors, GPS devices, 32-bit, 64-bit microprocessors are in, they've gotten cheaper, so they are in everything these days. RFID tags. So there's a lot of machine data, if you may. So this combination of human data, machine data, the volumes are very high, and a lot of this data is very sparse data. It is unstructured. There is no real structure to this data. But there's a wealth of information that is hiding in this data. And different verticals, based on what they are doing, are interested in analyzing a lot of this data as it pertains to the kind of problems that they are trying to solve. So the volume in this data is obviously huge. It comes in all forms, right? Like, it's not just structured data, which we as an industry have been, traditionally, we've solved that problem with relational databases. And it's getting generated at a very fast speed as well, right? So it's not just that enough to say that let's get our arms around, say, 2 petabytes of data. It continues to grow, right? Like, if you look at log data, for example, a lot of companies are sitting with many petabytes of data which need to be analyzed. But it's not just that they analyze what they have already, and that is going to be sufficient. 200, 300 terabytes of log data then gets generated every year. So what is needed is a new set of technologies to be able to handle, to be able to store as necessary this data, to be able to analyze this data, and to be able to do it in conjunction with the data that's already in the enterprise. So with big data, it's pretty key that we don't create another silo in the enterprise which only handles this new type of data. What we are seeing in most of the enterprises is that the CIOs, the CMOs that want to be making better decisions, right, they say that the rate at which this data is increasing, if they felt before that they were making decisions based on a subset of the data, now with this volume of data, that subset is it's shrinking, right? Because now there's more data to be analyzed. To start with, they were not analyzing all the data, and now there's even less that they are analyzing because this data is not even a part of their data platform. So one of the key trends that we are seeing now is that it's not sufficient to have a data platform that can only deal with fixed sources of data and can only deal with data that has structure to it. It's really important to build a big data platform that can integrate, it can manage all these different variety of data. It has to be scalable, that it can handle these large volumes of data, and be able to not just deal with this data or analyze this data in a batch-oriented manner, but also be able to do it in real time where extremely low latency is required for certain decisions to be made. Otherwise, analyzing this data is kind of useless. And I'll go through some of those examples. So the other aspect here of a big data platform is also that, okay, once you have ingested all this data, brought in all this data, and you have analyzed this data, now how do you make the results of that data, of that analysis available to the different users in the organization in a meaningful manner? So visualization of big data is also, there's a lot of evolution in terms of technology that is going on there. One other key aspect here is that, as this data is being analyzed, I was mentioning that, we cannot create another silo within an enterprise that only handles big data. Because when you look at, say, existing retail customers or, telco providers, they have some understanding of what their customers are doing with their different products, right? So they may have a CRM system, they may have a warehouse of those customer information. They'll have some kind of a transactional system that captures the transactions that those customers have made. Now, all of that information, they are obviously analyzing, and they're doing that analysis in the repository where that data is stored, be it the warehouse, be it any other file systems. It could be email archives. They are pulling that information and analyzing it closer to where the data lies. And now with big data, there are new kinds of repositories that are coming into the picture because these enterprises need a way to analyze, to store, to manage, to gain information from this data in a very cost-effective manner. So, we've all seen what has happened in the open source community with the Apache Hadoop project, for example. I'm not saying that that's the only way to handle big data, but that is a technology which is enabling a lot of ad hoc analytics to happen with big data. Now, but it's important that the analytics be done closer to where the data lies, because you can imagine trying to move petabytes of data around in an enterprise is not going to work. So when we talk about big data, we always talk about that do the analysis where the data lies. So when we look at, like obviously here I've put a picture which is the IBM's big data platform, but it doesn't need to be just IBM's big data platform. I mean, these are certain important components that you may want to think of when you are trying to figure out, what kind of a big data platform needs to be built. And so I'll talk a little bit in the context of what these components are. So what you see on as the Hadoop system, that is traditionally. So when we started with big data, everybody was big data equals Hadoop. But now what we are realizing after a couple of years of journey here, and my team has personally worked with about 200 customers in different verticals, that Hadoop is one component of the big data platform, right? So it's a component where you can bring in a lot of structured, semi-structured, unstructured data. It's not just limited to unstructured. We've seen customers bring in very large volumes of even structured data. Data which is noisy, where the signal to noise ratio is very high. And you want to analyze it, you want to do some kind of historical analysis. It's a good way to bring in that data in, say, a Hadoop kind of a repository. But Hadoop, Apache Hadoop, Hadoop and MapReduce, they were designed for a certain use case, which was, when Google and Yahoo came up with these pieces of technology, it was really to, you crawl the web, you search, you can query and do those queries in a faster way. Now, while that might be a use case, but in a lot of the enterprises, that's not the only use case. There are use cases that require extremely low latency. That data has to be analyzed, processed, cleansed as it is coming in, right? So there's no time that you can actually store it anywhere. You may need to analyze it while it's still in memory and has not been persisted. So that's where just having a Hadoop component in a big data platform is not going to do it. So, we at least provide something called stream computing capabilities. This is by no means that this is just, everything here is limited to IBM. There are lots of, plug and play kind of opportunities here as you're building the big data platform. And then, of course, there is the traditional, like where have people been storing this, a lot of the structured data. There are existing warehouses that people have. And it's important that all of this integrate with the rest of the enterprise data, because that data is not throwaway data either, right? You may store, say, 2 months of, say, sales data in your warehouse, but you may actually have 15 years of data that is available to you, which you may not want to put in the warehouse because of cost reasons. So that 15 years could be put in a Hadoop-based system, and only the 2 months that you need to access on a more regular basis, or the last 30 days, is what goes in your warehouse. But when you're analyzing trends, you need to pull data from your last 30 days, which may be in your warehouse, as well as the 10, 15 years of data that you have collected might be in your Hadoop repository. Right? And all of this maybe need to be correlated with some social trends that might be happening, and data needs that's coming in real time and needs to be correlated with all this other gamut of data that you have. Yeah, one of the retail customers I was talking to, so they analyze, every retail customer, right? They analyze their point of sale data to really do many things, but inventory management is one of them. Now, this particular retail customer, they would sell about 200 juicers every month, right, or every year. But the number was 200. That was roughly so that's how they would stock up in their stores. Last year, they found that more and more people were coming in to buy juicers, and they ran out of, they did not have that kind of an inventory. And what had happened was that there was a juicing video that had gone viral. And this is a big retail customer, right? This is not they have a worldwide presence and have been around for many years, right? And so this video, when it went viral, there were more people coming in the store to buy juices, and they ran out of them. And after their point of sale data, they were able to figure out after 72 hours that this particular thing had happened, right? But, so what are they doing now? They have realized that it's very key that if they had found or had been made aware of this hotspot happening in the social data, they could have done something about it. But this is a lost opportunity for them, right? Because that video is not going to go viral every so often. And when they analyzed, they found that as that video was going viral, that's where in those stores the demands of the juicers was going up. So it's not sufficient to only be analyzing your 30 days of data or transactions or point of sale data or your 15 years. It's important to be able to integrate the social data and have a big data platform that allows you to do all of it. And we are finding that like a lot of the retail customers, telco, they are integrating social data with their existing enterprise data. So this is a necessity. I'll speed this up a little bit here. That in terms of, like we talked about, that there is a Hadoop component to it. We have an offering here called Big Insights, which does more than Hadoop. So even though it leverages Hadoop, there are a lot of capabilities that we provide on top of Hadoop in terms of performance, reliability, security, in terms of analytics, because just ingesting and storing this data is not going to provide the insights that you need to make better decisions. So we provide text analytics capabilities, machine learning, a lot of algorithms which will help you, solve the kinds of business problems where you have to recognize patterns in a data and do something about it. And there's a lot of tooling that comes for application developers, for business users to really explore and navigate this data, to see the results of the analytics. There's a lot of stuff that is done here on top of Apache Hadoop. Then the stream computing capabilities that I talked about, right? This actually was developed after 9/11 happened, and it was really just for the US government from a homeland security standpoint. So it was done out of the research labs, working with the government to be able to analyze all kinds of data quickly, be able to filter a lot of the noise in the data, be able to transform, be able to correlate different data streams. This is literally like when we say streams, think of it as data streams being pumped in. And instead of traditional ETL, all the cleansing and processing and transformation is happening as these streams of data come in. There's a programming language that comes with these capabilities that helps you process and transform this data. There are analytics capabilities that are available that would identify patterns in this data and would indicate by analyzing all those patterns that this is an actionable insight that you should be looking at. We've done some work with University of Ontario here, which is, if you look at Data Baby, you'll find some information where there are 1,000 pieces of information that this is for a neonatal center where they take care of premature babies. And there are all kinds of KPIs that are measured to see what's the general health of the baby. And there's blood pressure, pulse rate, and literally there are 1,000 pieces of information per second, right? And they're coming in various data streams. It's not one data stream. And those get aggregated before they use this technology, it was getting aggregated to one reading, which a doctor or a nurse on the round would see that reading. And if that reading looks good, they say, okay, the baby is healthy. But what they started finding out was that babies that seemed healthy were coming down with infections. And they were like, well, there were no indications that this baby is going to come down with an infection. So using this technology and processing this data in real time and identifying patterns, they were able to predict the onset of an infection in a baby 24 hours in advance. which is a huge runway, if you think about it, for a doctor to do something. And this is not just, limited to something like this. We have, there are major telco providers using this to predict customer churn. And then we also provide, building blocks for these kinds of use cases to analyze log data, to analyze call data records, to analyze IPTRs, to analyze or ingest data that is coming from Facebook, Twitter. So because it's not easy to just be that we can ingest all this data. There's a lot of work that is needed to ingest this data, to cleanse this data, to write the rules that are needed to pick information out of this data. So that is something that we are providing in terms of accelerators. And all of these engines, if you look at it here, that there's data that can be shared across these components of the big data platform. There is analytics that is shared across these different engines. And like I was saying, that it's not like these have to be just limited to what I have shown you comes from IBM. But of course, we have taken, after working with a lot of customers, the initiative to really integrate these different aspects of the big data platform. And otherwise, you have to do it yourself. So in the interest of time, I'm not going to go through all of the use cases, but this is the applications of big data are in the energy and utilities industry. Cisco is one of our reference customers. They are using this for log analytics, they have a smarter building initiative. So again, a lot of sensor data coming from the buildings, analyzing that to figure out optimal energy utilization and what can be done by analyzing that data, to optimize energy utilization in buildings. They have taken this to other countries like China and Korea. And then, of course, log data has wealth of information in it, right? It could be used for preventive maintenance. So there are different kinds of, obviously, log files. They have their own format. How do you import these logs? How do you extract information from logs, correlate it with different logs? So they analyzed about 2.5 petabytes of log data, and they get about 300 terabytes of log data that gets generated every year. And they were able to come up with things which they were now able to use from a preventive maintenance standpoint. A lot of the smarter planet initiatives that you see at IBM, the underpinnings of that are the components of the big data platform that I kind of quickly took you through. Telecommunication, the customer churn, especially in Asia, around in telco is huge. And the volumes of CDRs and IPDRs that they have to analyze has phenomenally grown. So, how do you analyze this? The traditional approach used to be put a subset of this data in the warehouse, build predictive models around customer churn, leveraging data in the warehouse. And then if the new data comes in, then analyze and run against those models to really score if this customer is going to churn or not. Now what they want to do is they want to expand that. They want to, again, build those models using all of the data and not a subset of the data. And that improves the quality of those models. And then score those models in real time using something like stream computing, so that as call data records are coming in, using those customer churn models, scoring those in real time, they can really figure out, is this customer going to churn or not? So that's, I think, the power of the big data platform. And, like I said, there's a lot of material here. But for some additional material and information, I guess you're going to circulate the slides. So we have a Big Data University. We have a YouTube channel on big data where you can learn more about, in details about all of this. So thank you.
Thank you, Anjul. Now we have Sandro from HP. And Sandro, I'll let you take over. Thank you.
Thank you. Good afternoon. It's a pleasure to be with you today. My name is Sandro Maziotta. I work in HP Cloud Service. So HP Cloud Service is a business unit that is creating a new public cloud service. And I have the big challenge to talk about big data and cloud in 5 minutes. So but I will try to capitalize on the great introduction that we just had to really focus about what is the cloud and how the cloud can really help, let's say, to solve some of the problem that has been greatly introduced in the previous presentation. So I will go quickly through the introduction slide, but the idea is if we look at the evolution of IT and technology, we are the discussion is moving, let's say, from a small number of players, let's say, that was existing in the mainframe era, and it moved, let's say, first, let's say, a revolution that happened in our industry has been the creation of the client-server paradigm. And you saw already the number of players and, let's say, provider of solution increasing by being, let's say, more open. And when you look at now let's say the internet, this number of provider of information is still growing, and now, let's say, the time that we are facing and is what we call, let's say, the mobile and social big data and cloud space is even more increasing. So the number of data that is produced is growing exponentially, so it's probably not a big news, but let's say I like this chart to show, I mean, it's a very visual chart that show, okay, what are the amount of players, and basically all those players are creating new and new information. So it's a good explanation about, okay, why we see, let's say, all this data growing. The little chart on the bottom probably is a great visual chart that is also explaining the problem that we are facing in our industry, which is we are producing more data than we are storing. It's a problem for, let's say, the enterprise, for the consumer. It's a great opportunity and challenge for us provider of services, because we see a lot of potential in providing solution and a potential to make, let's say, some good business out of this problem. So the analysis is basically, or the key takeaway of this slide is, as it was introduced before, let's say, when you talk about this kind of volume, variety, and velocity, the traditional business intelligence tool era are not able to address the problem. So it's just, they have not been built to address this kind of problem, and it is our vision that basically, and following, let's say, also the idea of, okay, you need to build, let's say, BI capabilities or information or analytics management close to where the data is, because the data is now inside the cloud. So we have to create our own big data platform in the cloud. So that's why I would like to correlate, let's say, I totally agree with the vision that was presented, and I'm here really to talk about specifically, let's say, what we are doing in the cloud and to address, let's say, those challenges. So as I was just saying, okay, look at where we are, look at our society, what we are experimenting today. All those devices are, we are consumer either as a IT or let's say as an employee of big corporation, as a professional, or either as a consumer. We are producing a lot of data through all those devices, those great devices. I'm a big fan of those devices. And now the way, let's say, most of those services are architected, the cloud is becoming the backend. So all those clients are creating information or are soliciting, let's say, the creation of a lot of information, and the cloud is becoming the backend. So this is where the information is. And therefore, let's say, there is a need now to analyze, let's say, all those data directly when you are in the cloud. Obviously, an aspect that you need to think through also is, especially if we are addressing the enterprise market, for instance, is how can you perform some analysis about the data when it is, let's say, located both on premises and also in the cloud. So what are the kind of technology and tools that you are able to provide to the business user and not to the data scientist, you know? What kind of tools you are able to provide so that they can really analyze, let's say, and take some key decision when the data are located in the cloud and when they are located into, let's say, on-premise system. So probably the only commercial slide. It's a challenge for me as a product manager not to talk about my product. So it's also a great opportunity to talk about the vision. And most of the time, I'm not allowed to talk about the vision. People want me to talk about what is existing today. But I would say the previous CEO and let's say executive leadership really kind of realize, let's say, this trend, probably common sense, let's say, trend agreed in the marketplace, you know, and trying and really made a three strong bet, let's say, in terms of investment across, let's say, the HP portfolio, whether you are talking about the hardware, the PC, the storage, everything, you know. The idea was, okay, what people care, what our society care is about what kind of solution we can bring to leverage the cloud. Security is a very important aspect, and information and big data is another thing that we have been, let's say, focusing those last years. So as a matter of fact, the idea has been, okay, if you look at the bottom layer, we create data into every part of the portfolio. It comes as a result of a social media interaction, a video, a mobile interaction, transaction, anything is. So how can you build a platform like it was introduced before? So basically, those clever people acquired companies like Autonomy and Vertica to provide, let's say, value to the business user. So the goal was let's not deliver big data or let's say provide solution for only the data scientists and the people that are able to create the R kind of a very complex algorithm, but how can you provide tools so that it can consume, because big information matters. So how can you make it efficient so that the business user is able to consume it? So I let you browse the web about, you know, what Autonomy and Vertica are, but let's say this was just a demonstration about, okay, the HP move on the information and big data management. Let's say I'm much more also here to talk about what we did in cloud and what we see in the cloud. So also at the same time, we launched the idea of creating a public cloud, because the idea was for most of the consumer or IT professional will consume services and public services, and that's a growing trend that nobody can argue with. So it's just, you know, whether it is official, whether it is shadow IT in the enterprise, or as a consumer, I'm sure that every day you subscribe to more and more public services. The idea was how can we bring big data into the public cloud, and our vision, and it's not yet realized, but our reason, really the idea that we have is it's a two-way strategy. First, it means that we provide those vertica and autonomy, all the big data assets that we have, we provide them as a service for anybody to consume them. But also a second level strategy that we have is we are creating a platform as a service offering where big data will be an integrated component. So we will provide analytics and big data solutions so that the developer will have, let's say, all the tools to provide in his application big data analytics to the end user. So that's basically the building this next generation of platform as a service is the way we see we can address the problem of big data.
Next, we are going to have David Tennenhouse, who you have been hearing a little bit earlier, so I won't do any more introduction there. David, I think your presentation is going to come in from there. So,
okay, great, thank you. And let's see, I got equipped with yet another wireless device. So I wanted to just use a little bit of this time in the panel to build on the comments that I finished up with for those of you that were here at the keynote earlier this morning. Talking about the second economy. And to some degree, what big data is about, really, to my mind, it does a number of things for us, but a large chunk of the effort is about squeezing inefficiencies out of the system, right? So we have this opportunity to look at the data, identify inefficiencies, remove those inefficiencies, and those could be coming out of the supply chain. Okay. About that? So those inefficiencies could be coming out, within the supply chain. They could be coming out of advertising. Are we making the best, most targeted offers with the highest yield on our advertising? Are we getting our pricing just right? Sort of extracting top dollar from customers and offering incremental customers attractive offers, et cetera. Transactions, are we, the more efficient we make transaction systems, the smaller we can make we can afford to make the individual transactions. Now that's a great one because, of course, that just ratchets up the rate of transactions. So we start doing more and more finer and finer grained transactions. So from an economic point of view, what we're doing constantly is taking inefficiency out of the system. And one of the things I found interesting is a number of years ago, I started asking the economists, so how much inefficiency is there? I mean, sort of, is this a 2x? I mean, do I have room for, sort of 30% of the economy is inefficient? And, the thing that surprised me is the economists don't really think this way. From their point of view, it's unlimited, it's unbounded, which sort of is kind of worrisome because as an engineer, the other side of that coin says we're infinitely inefficient. But they just don't think that way. They just look at it as, if you take, say 50% out, now you've got a new economy that's operating at a new base, and you can keep taking, another 10% out of that, and then you've got, only a new economy at a base of 90% of the old one, and you could just keep going. And keep improving the efficiency of the economy. So unbounded is sort of nice, again, when you come from an engineering perspective and you're used to things being bounded and working towards, what's the limit of information theory tell us, et cetera. So Again, I was taken by Brian's essay, and I've worked with Brian in the past, so I wasn't surprised by this. And this is the chart I had before, so you don't need to reread it. But just the sense that now, you know, essentially big data and services are coming together because we're increasingly automating these services and essentially making all these business processes hidden and transparent, and automatically, using big data techniques, taking the inefficiency out of them. And all of that is sort of disappearing into what Brian called that second economy. So the thing I wanted to encourage folks in this group to think about are really sort of two things. One is think about that automation of services. So think of services as something that we can keep automating and improving the efficiency of, and moving more and more of it into the information side as opposed to necessarily the sort of people doing routine work over and over again. Now, you know, from Brian's point of view, and this is, again, these are all extracts, these are kind of, I'll say quotes, but the ... means I, you know, took substantial things out. So I apologize to Brian in cases where I probably mangled his text. But, you know, his observation relative to work and jobs was that as this goes on, more and more jobs are going to disappear. And those are both from, you know, developed markets and from emerging markets. In fact, many processes that are business processes that are being offshored today may be onshored again, except they'll be onshored through automated processes. So they're not going to create new jobs. The jobs are going to go away completely. Jobs that were offshored at some point in the past may just completely go away. So there is a concern there that, and in fact, it was interesting to me, I mean, the sort of third quote surprised me the most, and I haven't done the numbers, I'm not the economist, but his view that this effect could be so big that it actually may dwarf the effect of offshoring. So that's pretty substantial effect. So that's the sort of kind of negative angst concern. I'd like to sort of encourage this group to start some dialogue, whether it's in questions now or later this afternoon or whatever, about what I think of as the optimist perspective. And have people sort of think through that in the long term, certainly the developed world and many parts of the less developed world, so for example, China, a number of countries in the world are sitting on demographic time bombs. Our real problem is that we have a labor shortage. I know it doesn't feel that way right now because we're sort of going through a very difficult time, high unemployment in much of the developed world, and you know, slow productivity growth, slow economic growth. Not productivity growth is doing fine, but economic growth has slowed. But if we look sort of on a 20, 30, 40-year perspective, we have a labor shortage. And so we have this real need to start thinking about this ability to automate processes, et cetera, as a way of freeing up labor. And what we're really going through now in this period of unemployment, I'm giving you the optimist perspective, is an unparalleled opportunity sort of to have liquidity in our labor force, and probably for the last time that we're going to have in the next 20 to 30 years, a chance to actually rethink where do we want to target our labor in the future. So I'm not going to claim to have the answers to those questions, but I'm going to say that, you know, it definitely is a cloud. I hate everything that unemployment is doing to our society and the negative impacts it has on individuals and families. But the silver lining on that cloud is we have an opportunity to rethink where we want to position our long-term scarce labor resource going forward. What are the things that are really important to our society? Seizing on some of Raj Hazra's comments about democracy, et cetera, what are the things we really care about? Where can human beings really make a difference? And how do we get sort of our future labor force, the children we're educating now, the students in college now, targeted in the places that we think will really make a difference to our society going forward? So that's I think of that as the third economy. If the second economy is all the stuff that's getting automated, what are the new activities, new places we want people to go into in the future? So I'll leave those thoughts for you to discuss, hopefully, in the future.
Thank you. Thank you, David. Let's see whether my projection system is working. It's plugged in. You got it? Okay. Hopefully it'll be there soon. But while that's coming up, I'm Arijit Sengupta. I'm the CEO of a firm called Beyond Core. Extremely small firm, but we have fun because we got the Gartner Cool Vendor this year. Actually, I know Jinesh is there, but we beat Amazon, Salesforce, and VMware on a competition for most innovative cloud computing company. Oh, he's got the slides up. No, it's still David's slides. Well, I'll just continue while the slides come up. It's been fun being a really small company competing with the big guys. You want to try one more time? Yep, I did that. Mm-hmm. So what I'm going to talk to you about is advanced analytics, but I'm just going to try to provoke a couple of controversial points. First thing is, you might have seen this graph from LinkedIn, which talks about the growth for data scientists. And the question is, are data scientists going to be the new elite? Quite possibly. But here's what I would want to point out to you. The access to analytics is broken today. If you think of the organization, senior execs, and I'm actually weighing by numbers. Of course, there are not that many senior execs in a company. But if you think of the impact a group of people have on the future of their company, the senior execs might be the top of the pyramid, but they don't consume all of the potential impact. The majority of the organization actually creates the impact, but the access to analytics is just the opposite. The senior execs might even have too much access to analytics, but down at the lowermost levels of the organization, they don't. And we're going to come back to this at the end because I want to end with an example of where I think a massive company lost a lot of money precisely because of this problem. Now, I claim everybody needs access to big data and advanced analytics. And you might say, okay, you're crazy because we just heard about velocity, variety, and volume, and I don't need terabytes of data. But the point is, big data is also about complexity. If you have lots of variables you want to consider, that's also hard algorithms, hard analytics, and that's big data too. Now you might say, oh, I don't need that. Now, let's say I show you this graph and say drug 3 is the best drug. If you take this drug, the disease doesn't relapse very quickly. But then I show you this drug and I say, but drug 2 is actually better for women. Then I show you, and drug 2 is also better for Asians. And by the way, you may not know this, but many drug trials don't include enough women. So the drug trial results are actually biased towards men. Okay? Now, if you are an Asian woman, which drug would you want to use? The answer just flipped because we looked at multivariate analysis. So if you're sitting there saying, I don't need big data, you're missing the point. Every single one of us need big data all the time. It's just a different way of looking at it. The problem with this kind of statistics, though, is if there are 10 fields in the data, very small amount of data, you need to look at 10 graphs to analyze the information. If you want to look at 2 variables, you're at 90 graphs. If you want to go to 3 variables, you're at 720 graphs. Do you really want to look at 720 graphs to figure something out? Any of you want to have that job? Let's go to big data, because what we are hearing now is hospitals want to look at more and more variables to try to predict where infections are happening. Banks want to look at more and more information to figure out what their risks are. But the moment the number of variables start increasing with just 100 fields is not that much, we are at 94 million graphs if we want to analyze all possible data combinations. Okay? That is just not possible. So I like the fact that the need for scientists is going up, but the reality is you cannot solve an exponential problem with human growth. It's just not going to happen. You can train as many people as you want. You can move as much work to India and China as you want. You're not going to solve the problem. Okay? So this is what a SAS code looks like. Quick disclosure, I have a degree in computer science and a degree in economics from Stanford and an MBA from Harvard. I can't write SAS code. I've tried. I suck at it. Okay? It's hard stuff. But the problem is, you couldn't solve, even if you could get everybody trained to do SAS, you couldn't solve the problem anyway. You have to do this without requiring computer science and statistics skills. So I went to my developers and I said, guys, you know what? Build me an analysis product that doesn't require statistics and computer science skill. The problem is the only people who can build this, and Anjul hires a bunch of these kind of people, they are amazing at statistics and math, right? So one of the guys in my team has gotten the perfect score in the International Math Olympiad 4 years running. Guess what? What he thinks is easy statistics is crazy hard for the rest of us, right? So asking the few people who can actually do this right to make it simple almost doesn't work. And that's where we are stuck as an industry, many of us. So I gave them a very stupid requirement potentially, or I think it's the best requirement I've ever given anyone, which was no keyboard. Build the darn product without requiring a keyboard to be used, and you'll find a lot of organizations are moving to this. They're moving to a mobile-first strategy. Because the moment you give them a lot of space, people make products complex. You force them to make it work on an iPhone, suddenly things become very clear. I see Anjul smiling there. And that does change advanced analytics. And I think that's where we need to get. Power is great, but if it doesn't have impact, it's useless. I also think we have come to the point of death of reporting and dashboarding. How many people have dashboards that they use all the time? Anybody? Okay. Anybody ever took an element off their dashboard? When was the last time you took something off your dashboard? Okay, people are smiling. The reason is you keep looking at the same stuff even if it doesn't matter anymore. What you need to know is what has happened today, this month, so that I know what's important to me today. So dashboarding is like fishing. If you know the right spot and you stood there and you caught the fish and you're a good fisherman, you're going to do great. But if the fish move, you are dead. And that's the problem. What big data and advanced analytics is like is a fishing trawler. First, you're going to use a sonar to figure out where the heck the fish is. Then you're going to put up a wide expanse and you move with the fish and grab them all. That's where you have to get to. But of course, you can't bring that huge amount of water with the fish. Just get the fish. That's where we need to get to. So yesterday, my belief is, and I'm sure, anybody not had this moment where you screamed at a computer? I've had that happen to me all the time, right? Yesterday, it was all about us serving the computer. I love the fact that we bow to a computer all the time, right? I'm bowing to the computer right now. If aliens came to Earth, they would think the computers were our gods, potentially. Tomorrow, though, is about computers training to serve humans. And give a child an iPad, and you'll be surprised a 2 or 3-year-old will start interacting with it and start using it. And I love that. That's the future. But how do we do that? By the way, I came to the US to study artificial intelligence. And it was the most boring class I've ever taken. Actually, don't tell Daphne Kohler, she'll kill me. I've had some amazing professors. But it was boring because all you do is you rate stuff, you classify stuff, you provide feedback, and you wait for that computer to learn. Horribly boring. And then I realized we train artificial intelligence every day. You have done it. There's nobody in this room that has not trained AI. What do I mean? Did you watch a movie on Hulu? Did you use something on Netflix? Amazon someone? LinkedIn? Every single one of these things use social feedback to train artificial intelligence. So today, if you think about social, don't add social to analytics just because it's cool. Add it because when you allow people to interact over information and you can have a factory manager answer to a question from their boss saying, why is this product slowing down on this month? Right? You let them interact with each other, but then you track that human interaction and learn from it to figure out which reports do people look at more often. So you can turn it around, turn social into a means for artificial intelligence, and you don't have to have boring training activities anymore, right? So that's the future. Why does cloud fit in? I think, again, letting the computer serve us is all about on-demand access to power as desired. So if I want to access something over an iPad, over my laptop, I shouldn't have to worry about it. If I need compute capability for 1 hour, I shouldn't have to worry about it. That's all about letting the computers serve us. Finally, I told you I would finish with a story. By the way, I didn't do any slides on Beyond Core, really, so I'm going to finish with a demo for 1 second. Look at Wells Fargo. They got into a problem with actually, statistics is what got them into trouble because the government figured out that there was bias for certain races in their mortgage setting. Now, imagine people at Wells Fargo had access to a simple analytics tool which went in and told them what matters. So this software is telling you that there is no bias at the first order level for race, but it's saying, hey, processing officer race has a bias. This is important. Let's take a look at it. I click that graph, and you know what? I find that for race 3, this officer is sticking out. I may not have known to look for it, but if a computer can tell me it is important for you at this moment to look at the combination of processing officer and race, and with one click tell me where to go, and in fact, this does more interestingly than that. It tells me that it was race 3 and processing officer 6 that was the problem. If I click on it, I get processing officer 6. That's the future of analytics. Not just about power, but making it simple. Going back to the slides. So you heard from each of our panelists. Let me just go back to each of the question areas, and hopefully this other mic will work. I would invite each of you to add to the themes we already heard today. Anybody wants to add to something on big data and advanced analytic concepts that we didn't cover?
Yes, I'd have a couple comments on some of what we've heard this morning. One is I think and I think Anjul, you sort of talked about it a bit, the importance of temporal information, which is it's not just, it's sort of the combining the real-time information I'm getting now with the history of all the information, all the events I've had in the past. And whether you're doing that with streaming, with a temporal process or other, there's a few other technologies coming along to deal with this. But it's really having that combination of what's happening now with the history, all the snapshots of the history of what's happened in the past. So I think that's one key aspect of big data. I think another is the ability to basically combine very, very heterogeneous data sources. And we didn't really talk about that very much, but I think we're probably all doing it and all involved in it. The simple examples are combining your local information of, say, your location. Here's where you are now, and here's your past buying pattern. And that probably tells me a lot about what you might do next in terms of purchases, given where you are right now. Where you're located. So combining information from multiple data sources and fusing those together, I think, is a key piece. It's not just about going through your own logs, and this is where I think there is discussion about brokerage. It's not just, you're going to have to integrate information that come from other people's sources. It's not just the info that you collected yourself about your customers, but what other information can I import from others in a privacy-safe, privacy-neutral way, and now extract interesting learnings from those combinations. And really, I think of what we do in data, what I talked about this morning about getting information from the physical world, that's about increasing the number of bits we have. And then what we do with information processing is extract the interesting permutations. And if you've got n bits, there's 2 to the n permutations. So there's, as you were indicating, a lot of possible things to go through. So extracting those interesting permutations from the combinations, including data that belongs to other people and that we need to get access to. And then I think a final thing which perhaps relates to the last comments is got to do with inference, right? It's not just about correlation, it's about what can I infer, what's the cause and effect. And there's something I've been fascinated with for a long time is people are not actually, on average, all that good at coming up with hypotheses. They look at something and they come up, and all of us have done this, right? Even those of us that think we're pretty good at this often come up, let's say you're trying to debug something, whether it's a computer program, a process, a system of any sort. We tend to think we've found the bug many, many times, only to find out that wasn't really it, or it wasn't all of it. It was only part of it. And so even those of us that are pretty good at this aren't as good as we would like at coming up with hypotheses. If you look at the science world, only a small number of people are really good at coming up with hypotheses, and most people spend a huge amount of time pursuing hypotheses that aren't going anywhere. If we could use big data to infer and come up with, you don't have to get the right answer. So that's what I think is interesting, and you were sort of hinting at that with the last example. If I could sort of go and give the analyst, here's a few good hypotheses, here's the top 10 best hypotheses, and then let the human being run those down to figure out which of those is really good, which one's right, which one do I want to bet on, I think that would be a great system. So what I'm saying here is we don't have to design systems that can get the inference perfectly, if they could just give us a small set, a tractable set of hypotheses to work from, I think then human analysts could do much better and we could work together hand in hand. So for what those comments are worth, I'll stop there.
I'll actually give you a funny example of what you just said, because the hypothesis the client had on mortgage scheduling problem, they were trying to schedule mortgages to operators so that they would do efficiently. And they had these highly skilled operators. So the analysis shows that they do horrible in terms of how much time it takes them to do mortgages. And we were really confused, like, why is this happening? The most skilled guys are actually doing worst. It turned out they were incentivized on how many mortgages they did a day. Now, if you're experienced and smart, what do? You see an easy mortgage, you finish it off immediately. It's not first in, first out, it's kind of the easiest in, first out. And so, of course, you'll do a great job on the thing you're incentivized on, but messing up the client and the organization, right? But doing a big data approach to it, which quickly shows where to look, transforms it from something they couldn't solve to something they could solve in one conversation.
Yeah.
Also, sorry, thanks. I believe also looking at the slide, yes, we need to provide the tool, or let's say the analytics that are easy to be consumed to the business user, to the user, to the consumer. I don't need to be a data scientist to consume this. But the point we would like to make also is let's also give the developer of the application of tomorrow the ability to kind of not look at whether this requires a SQL data, a NoSQL database, whether this is structured, unstructured. I mean, there is a lot of discussion in the IT currently about, what are the tools, what are the best things, what are the new paradigm. I mean, we will do a better job as an industry if we also make the life for the developer of the new application, of the kids, of the startups, the guys that have this great idea and that want to create analytics inside their application to hide this complexity. And that's probably also another action that we can take as a community to provide, let's say, a better world.
So I just got the instruction from Chris to move this along. So why don't we ask if there's any questions from the audience? And please come find us and get involved with the SIG focused on big data and advanced analytics to continue. Yes, question back there. Can we get a mic to him? Do we have a mic? Okay. Yeah, thanks.
Hi, hello. Thank you for your talk. It was very interesting, all of them. My question relates to the second economy concept, and very specifically, for example, if you think of all of the uncontrollable or unexpected implications of having all of these services running automatically, like, for example, what happened on the flash crash. So having all of these algorithms trading, and basically then the whole market collapse. So how we can control and how we can basically build systems that are resilient to these kind of episodes.
So if I understand you correctly, you're asking when you have automated trading systems or automated systems that are acting when there are unintended consequences to that. Anybody wants to take that?
In my proactive computing challenges, you'll notice one of the questions that I think people are still working at is how do we manage when we have millions of feedback loops operating simultaneously and they're interacting and affecting each other. And I think there's progress being made on that problem, and I'm now talking at a research and theory level, but it's still a very hard problem. I think that overall we have to, on a broader kind of societal level, we've gotten much better at building robustness and resilience into our programs. I think in terms of how cloud-based computing works, if you look at most sites like Google or Amazon or others, the site as a whole essentially doesn't go down. And I'm not talking about the Elastic Cloud now, I'm talking about the Amazon website or the Google website, et cetera. individual features within those sites go down. So that people have actually gotten good at understanding what's essential, what's not, and allowing the system as a whole to present an image of working effectively to the user and getting done what the user needs, even though significant parts of that system may not be working at any given point in time. Right? So I think we've actually, there is light at the end of the tunnel. We've gotten better at this. I think you had a specific question related to what happened, when the Elastic Cloud went down and had a failure and then lots of websites went out at the same time. Was that? Oh, when the exchanges get into trouble. And I guess what I would say is a couple things. One is we are getting better at having these things happen less frequently. They are going to happen, and in fact, there's even some, believe it or not, control systems theory that says you need to have these periodic significant failures in order to have people continue to improve the system and work the system. And if, the longer you go without a significant failure, the bigger the failure will be when you have it. Right? So we shouldn't expect to get rid of this entirely. The good thing at some level with these trading system failures, et cetera, it's not that they're, that we want to see them, we don't want them to be, happening on an ongoing basis, et cetera, but, let's face it, people don't die. I think, it's not a disaster, it's highly undesirable, but it's not, a disaster with millions of people being endangered when we have that sort of failure. I think what we have to look out for and be very careful about are the failures that are really going to be life and death situations. And that's something that we do need to be careful about, because increasingly the internet and our technology is being used for, what I think of as truly mission critical life endangerment situations. That's kind of my bigger concern.
As an engineer, I'll add one thing, which is you have to be a little arrogant to do something new, but you shouldn't be so arrogant to think you're always going to be right. So the best programmers actually do put into checks things like that. If I suddenly see a very weird outlier happening, the outlier should be recognized and dealt with. That's part of having an automated solution. So that's just a sign of bad programming, not of, the concept isn't bad, it's bad in execution. Question up here.
This is a question regarding the, stepsister here, which is big data has come today, but classical, I like the Arijit's company because it's dealing the earlier majority of the analytics, which is around statistics. But I like to point out here one major challenge we are facing in real customer scenarios is big data is advocating things like NoSQL, real-time stream computing and all. But one of the first things people have come back and said, we have been teaching computer science SQL. Now you're coming and telling me we have to disband our relational databases and you have to bring all these Cassandras and all the Mahoots. So the two part, in fact, it plays out in both sections, both in terms of the analytics techniques, etc., where statistics is suddenly forgotten, except companies like Arijit. I have a lot of respect for you in that sense. So people are all talking about text mining, but where does the classic, even we're not achieved perfection even in statistical analysis and giving a reasonable visualization to the KPO guys who actually work with ZZ and 1,000 columns beyond ZZ. Think around it. And so I think somewhere big data has misplaced been misplacing the notion that everything now is big data. But I think 99% of the world is still working on classical analytics. So want your feedback from everyone.
So it's a good point, right? What we are seeing is that a lot of the NoSQL kind of technologies that are being leveraged are a lot by the web internet companies, right? And in those cases it might make sense, but a majority of the enterprise customers, they have major, and rightfully so. I mean, so first and foremost, I guess I have to say that it's not like databases are going to go away, right? There is the kind of applications and the business intelligence that people were gleaning by storing that data in databases is still needed. It's not that's not needed. Again, from a transactional standpoint, there are certain transactions which still, like 8 out of the 10 ATMs are still running on mainframes, right? Because that robustness is needed, the high availability is needed, the scale is needed, which is not to say that, could some, not maybe in the banking industry, but could there be, like when we look at now, the online shopping, for example, there is, people are browsing, people are looking at various products, they may be putting stuff in their wish list, for example. And so what is the retail industry calling them, right? So one of the customers tells me that these are our sub-transactions, right? So the transaction itself is still, when did somebody actually buy stuff, right? But everything that they do prior to that is sub-transactions. Do those sub-transactions need to be on a robust system? Maybe not. Do those sub-transactions need to be analyzed to understand the customer behavior and, what are they buying, where are they browsing? Yes. If they were only continuing to analyze that actual transaction, then they will be missing out on insights, which these sub-transactions, which are actually, for every transaction, there may be a large volume of sub-transactions that happen, and that needs to be analyzed. So could that be done outside, because that's again a lot of noisy data, so could that be done outside the warehouse? Maybe, right? But so it's a combination. You need the old business intelligence or how, those reports and all of that doesn't go away, but it needs to be augmented with, because internet, web has just changed, and mobile devices, it's changed the world around us. And a lot of the interactions, sub-transactions that are happening on those devices or those media needs to be captured and analyzed and augment what you already have in your warehouse. And so, there is the SQL layer, right, is still being extended so that it can go against not just those traditional databases, but also against some of this unstructured data, because that's where a lot of the customers are and are pushing. At least, that's like IBM is certainly doing that, right? But overnight, you can't, the NoSQL technology is not going to catch up with what has been spent over the decades in the relational side.
I got the hook at this point. Given we got the hook, yeah, go ahead, Chris.
Subject of big data, we talk about Amazon as like a key player.
Jinesh, you want to come?
Put him on the spot.
Put him on the spot. That's what Chris does.
So Srini asked a very important question. I think it's the way to analyze, and it's important to understand where the importance of big data is. So in the old days, senior execs will come to us and say and ask a question that, let's say, I want a nightly sales report of every single product, right? That question drove the data model. That data model drove the way how we store data. That how we store data drove how we collect and get the data in the first place. So what inherently wrong is, or the most important thing that is wrong in this scenario is that it becomes prohibitively expensive to run ad hoc queries. So when I have a question of very complex question that I don't know where I want to ask upfront, I have to take a complete full scan of the data, of the raw data, pre-compute indices, and actually keep that data as is. So it is extremely important to understand that was the reason how these relational databases and the schema models and everything worked. But now what we are seeing that execs are coming up with saying, I want to measure everything. collect as much data as you can. It's a data-first philosophy, right? So in order to really measure that, they want these schemaless models, easy to change. They want Cassandra and others, which are easier to scale than relational databases. And that's why these technologies are really making an impact today. So big data is all about, when I say it's storing, sharing, analyzing, processing, distributing, and visualizing all this information so that you can distill knowledge out of that data and take business actions for that as quickly as possible. So these new way, because we are seeing this much data coming in all the time, and every slide I see is like saying this many zettabytes of data in 2020 and this many petabytes of data will be there. This whole data first philosophy is driving this new change, and in a way my cloud is really enabling and powering that in a way. So just my 2 cents.
Thanks, Jinesh. Be careful. Chris is planning to get you into the big data SIG. I can figure that out. I really think we need to finish it off at this point, but so the 3 things we are driving is, of course, figuring out what the concepts are, better defining what big data means, what analytics means, going beyond just the 3 V's and seeing what else should be there. On the ecosystem, looking at every layer of the organization, trying to figure out how they can collaborate to have an impact together. And then finally, what do we need to focus on to solve the client problem? For example, we're actually creating some problems, like big data has made the privacy problem much worse. There was a demo from IBM that scared me a little bit where they showed us how they can figure out what Twitter account matches up with what Facebook account with what employee record. It wasn't a public enough place, so I hope you don't mind. But it's a little scary to think that what I said on Facebook and what I said on Twitter might be tied to my corporate account, right? How do we solve that also? How do we rethink privacy in that world? So that's what we are going to be focusing on. Could we finish with just a sentence or 2 from each of you on just a call to arms for this group? What can we do together to have an impact? Shall we start from you?
I think the biggest thing, since this is a service-oriented group, is think about the service aspects of big data. And as I've said, particularly, how do we make things more autonomous and reduce the amount of drudge work involved to get things done?
Yeah, I would say as a cloud service provider, we are mostly gluing a lot of technology, and currently the lack of standardization around this new problem, basically, are kind of killing us, because to be cost efficient and trying to go to market quickly, the amount of integration that we need to put in place would be better if we have like better bodies, standard bodies that can help us with reference architecture and reference APIs to integrate all the players from the ecosystem.
Yeah, so this is certainly still a start of a journey, and while there'll always be leaders who will be who have embraced this and are already in production mode, but a bulk of the customers are still trying to understand, what are the use cases, how do we leverage this data. So from the standpoint of what we can do together, building some kind of reference architectures, marketectures for these different kind of use cases, at least I think there is consensus on what are the first set of problems or ROIs that businesses or senior execs in those businesses want to see, or what does the chief marketing officer want to look at. So, to the extent that we can make it easier for them to help them understand how they can get started, what kind of, again, like I said, reference architecture, both in terms of hardware, software, services. What does the architecture look like as they're trying to bring in, say, social data in the enterprise? If we make that little bit more prescriptive for them, I think you'll find that, together we'll be able to make a lot of these enterprise customers see the return on their investment.
Thank you very much. As regards me, I already told you through the SIG what we are doing. come find us, ask us questions, help us make an impact. Would you please join me in thanking the panelists? Thank you.